All right, hello people watching this video. We are doing the last little bit of 7-6. 7-6 was like adding and finding common denominators and doing all that stuff. So these are all mixture problems, okay? And so we're gonna do, here's what we're gonna do together. We're gonna do this problem together, and then this one will be homework, right? It's exactly the same, but starred problem together, homework is the number one, okay? We're gonna do this starred problem together, and this is homework. Okay, they're the same problem but using different numbers. I just want to make sure that you guys know what you're doing, all right? This one we're going to do together, this work problem, okay? And then on the back side, we'll do number 3 together, but I'll have you do 4, 5, 6 on your own so you get the idea. All right, I'm going to erase the stuff from last year. Okay? All right, you're going to be drawing a number here in a second that tells you how productive you are, actually. In these work problems, like how fast can you paint a house? I'll give you a number and tell you how fast you can paint a house, okay? So that's what we'll be drawing here in a second. To everybody who's watching this video, I'll give you a number as well, all right? So mixture problems, just on the front side, we don't need a number for that. We're gonna go through these and then we'll draw numbers. Here we go. Mixture problem, okay? These can be kind of tedious, so it's a little bit confusing. Just stay with me as much as you can, all right? These boxes right here kind of have a way of like sorting your thoughts out a little bit. You can do these without having to have the boxes. I'll kind of explain the boxes as we go through, but I'm just going to read the problem. We're going to write some stuff down and we'll see what we got, okay? All right, first thing, how much, we're trying to find an amount, how much of a 70% acid solution should Maya add to 12 milliliters of a 15% solution in order for that solution to become 60% acid, okay? So here's what we have. We have a beaker, if you need a visual, that is filled to 12 milliliters, okay? And its concentration is 15% acid, okay? So not very acidic, not too bad, right? We are adding to that, we're filling that up with 70% solution. We don't know how much we have to add, probably quite a bit though, because I want that 15% to now be 60%. So I would imagine that to raise it from 15% to 60%, I would probably have to add quite a bit, right? It's already at 12 milliliters. I don't know how much I have to add, but I want it to eventually level out to be about 60% acid, right? Like that's what I want to have happen, okay? All right, so here's the deal. They kind of have our thoughts sorted out right here. What I'm going to write off to the side over here is going to look pretty similar, but I'm going to do like the old plus what we're adding is going to give me the new amount, right? Old plus what we're adding gives me new, okay? That's kind of like just a way of sorting our thoughts out to begin with, all right? And the way that I'm going to boil this down to is that our old, whatever we have 2 things that it gives me about the old. We know that it's 12 milliliters, and we know that it is 15% concentration, right? Okay? So what we have is we have the amount. I'm going to write this over here. Let's put it in a different color. We have the amount times the concentration plus, I'm going to do an amount over here for what we're adding times the concentration is going to give me a new amount times concentration here. We're just going to fill in what we know, right? So I know 12 is the amount times the concentration of 0.15. We're going to add that to what we're adding, okay? All right, so what do we know about what we're adding? What are we adding to the 15% concentration? We're adding 70%, so that's my concentration. How much are we adding?
We don't know.
We don't know, so what do we call it?
X.
So X amount at 70% concentration, right? This is the amount, this is the concentration. Got it? Okay, now the new concentration I want to be how much? 60%. Okay, what's the amount going to be? How much is my final solution going to have in it?
12x.
Not 12x, you're close.
1.2.
Nope. Let's say we were adding, I don't know, 20 in there, right? What would be my total concentration afterward, or total amount afterward? 32.
What?
32, right? Yeah? Right? If we're adding 12 in there. So what's the equation going to be?
12 plus x.
12 plus x, right? Not 12x, 12 plus x, right? Do we see how that works?
So close.
Okay, then we're just going to solve stuff, right? We have our equation. We're going to solve stuff. So can you take 12 times 15, or 0.15, I mean?
Yes.
What is 12 times 0.15?
for me.
Who knows?
I don't have
I
calculator.
don't know. I think it's like 1.8. Somebody calculate it for me, just to check to make sure. What is 12 times 0.15? 1.8. Okay. What is x times 0.70? 0.7x, right? I don't necessarily need the 0 on the end there. Okay. So I've got plus 0.7x equals. Now what do I do on this side? Multiply. I can like back distribute. What is 12 times 0.6? Do you know what 12 times 6 is? 72. So what's 12 times 0.6? 7.2. Okay. And what's 0.60 times x? 0.6x. Okay, now you get to this point and you can totally solve this just using algebra. I don't like decimals. I don't like decimals and I don't like fractions, right? And each one of these numbers has a decimal on it. It has one decimal place. So, do you know what you can do to make life easier? Take everything, the whole thing times 10. Distribute 10 through to everything, right? If it had 2 decimals, you would take it times 100, right? Okay, you might have done that like in 4th grade when you dealt with like penny and nickel and dime problems and stuff. Okay, so 1.8 times 10 is 18 plus 0.7x will become just 7x equals
72.
72 plus
6.
6x. Okay, all right, now we keep solving. What would you like to move?
Minus 18.
The 18.
You want to move the 18 over? You guys move that number first. I always move the x's first. That.
Me too.
Okay, minus the 6x. You do not. You're the one that always moves the other numbers first that I get after. 7x minus 6x is? X equals?
52. No, don't do it. 54. Yeah, 54.
54. What does that mean?
What is it?
That's
That's the new amount.
That's what you have to add.
12.
Holy crap. We started with 12 milliliters. Why do we have to add so much?
To have it to 60.
We're going from 15% to 60%. That's like quite an upgrade, right? Like we're gonna have to add. So that means total. They didn't ask for this, but total, how many milliliters is my solution going to be at the end?
66.
66 milliliters. So I better have it in a big container to be able to add that much, right? Okay. That's how much I will have to add. Your final answer is 54. Okay. But just keep in mind that means that your total solution is going to be 66. Do you see how that works? Okay. All right. Can you model number 1 after that?
No.
Number 1 is going to be exactly the same, but just with different numbers. All right.
I hate it.
Can we save that and go down to the next distance problem? This one is the hardest one. And then we'll get back to an easy one again, right? So distance problem. Ready? Here we go. Okay, distance problem. Sandra's canoeing rate in still water is 6 miles per hour. All right, I'm going to draw a little visual over here. So we got a little canoe, right? And she can go 6 miles per hour in still water. In still water. That means like no current, right? How often are you canoeing in still water, though? Maybe on a lake, you might be in still water, right? But if you're going up and down stream, you're probably going to have a current with you, right? Okay? So what's happening is that she's going, and then she's coming back, okay? And let's say she's going like with the current, okay? So she's going 6 miles per hour, but let's say the current is like 2 miles an hour, right? Let's say that with the current, the current is 2 miles per hour. Don't write the 2 down, because that's just hypothetical. We've got to figure out what the current is. Let's say she's going 2 miles per hour, right? The current is. How fast is it going to feel like she's going?
6 miles per hour.
No, 2.
It's going to feel like she's going 8, right? Okay, now let's say she's going against the current. How fast is it going to feel like she's going? 4, right? Okay, so 6 plus the rate and 6 minus the rate, right? Like going and coming back. Going with the current, against the current, it's going to feel like she's going faster. With the current, against the current, it's going to feel like she's going slower. Got it? Okay, so that's how that works.
Got it.
Okay? Now, it says that, we haven't even read the rest of it yet. It takes her 3 hours to travel 10 miles. Okay? Now, if she's going 10 miles, I'm going to pick apart that real quick. If she's going 10 miles, it is going to be 5 miles going there and 5 miles coming back. You agree? 5 miles and 5 miles, okay? If it takes her 3 hours to do that, does that necessarily mean it's an hour and a half there and an hour and a half back?
No.
No, because if she's going with the current, she's going faster. It might only take her 2 hours to get there, but an hour to come back, right? When I was in college, I went to England for like 2 weeks, and going took 7 hours, but coming back took 9. That's not taking into consideration like the time difference or whatever, right? Like that was like actually 7 hours on the plane, actually 9 hours on the plane, right? Because we were going with the wind speed, right? And you're gonna have a wind speed example on number 2, okay? So that's how that works. So even though it's 5 miles and 5 miles, going and coming back might not necessarily be split in half, right? 3 and 3 or 1.5 and 1.5, okay? But we know that the time going plus the time coming back is equal to 3, right? The time going there and the time coming back is equal to 3. Got it? That's added together. All right. We're going to do some physics now. Not physics, maybe physical science. I don't know when you guys learn this. Do you guys know that distance is equal to rate times time? Okay, like you may probably just know that from like basic math, right? If I'm going 60 miles per hour for 3 hours, that means I can go 180 miles, right? Like distance equals rate times time, okay? Now, maybe what you didn't know is that if we're talking about time, I can divide by r over to the other side, and the time that it takes to do something is the distance divided by the rate at which I'm going, right? So if I'm going a distance of like, let's say 300 miles for 60 miles per hour, how many hours is it going to take me? What's the time going to be? 5, right? Like I can do it that way instead, right? Distance equals rate times time, but time is equal to distance divided by rate. I can do that, right? Okay, so back over here at time. The time going is the distance divided by the rate, plus the time coming back is the distance divided by the rate. And we know that that's equal to 3. Time going plus time coming back is equal to 3. Got it? Okay, let's talk about time going. Distance. How far are we going distance-wise?
10 miles.
What's the distance going?
10.
What's the distance going? 5. Right? And the distance coming back is 5, right? Okay. Now, what's my rate that I'm going?
6.
If it's in still water.
What bit of water?
8.
Okay, if it was 2. Okay, so it's 6 plus whatever the rate is, right? Okay, that's my rate that I'm going, right? It's 6 plus whatever the rate of the current is. Okay, the rate that I'm coming back at is going to be 6 minus the rate, right? Okay, depending on the stuff. Where do we get the 5 from? If it's a 10-mile round trip, it's 5 going, 5 coming back. Got it? Okay. Other questions? So that's where my numbers come from. 5 is going, coming back. 6 is in still water, but I have to add the rate to that and subtract the rate of the current from that coming back, right? Equals 3. Got it? Okay, now, how do we add these two together and equal 3? Those are my 3 pieces. Plug in answers and see what you get, right? But it could be a decimal, so you could be plugging in all day long, right? Yeah. Okay, 3 as a fraction is 3 over 1. 6 plus r, 6 minus r, and 1. Let's find a common denominator. Common denominator. You got to write kind of small because we got lots of room to lots of stuff to do. Okay, ready, set, here we go. What's your common denominator going to be? All of them. Except really the 1, you don't really need 1 in there, right? So we got 6 plus r times 6 minus r. And we got 6 plus r, and we got 6 minus r. And we got 6 plus r, and we got 6 minus r. Okay, there's that. My tops are going to be 5 and 5 and 3. And now we just have to multiply by what he needs. What he needs, what he needs, what he needs. Okay, questions on what we're doing? Questions on where we get the numbers from? It's kind of a tedious deal. There's a computer system somewhere that sits there and solves this stuff like
What's it called?
on a daily basis. I don't know what the computer system is, but they got some computer system set up because you ever like wonder, you know, like I just told you going to England and coming back from England, 1 hour, one was going 7 and one was going 9, right? but the wind changes speed, right? Like it's not the same speed every day. So there's literally a computer system that's calculating all that stuff so that like my family at home, when they're sitting in front of the monitor waiting for me at the airport, they know that I'm coming in exactly at 4:02 p.m. You know, like they have some computer system that's calculating this for them according to the wind speed and how fast the plane is going, that knows she's going to come in at exactly 4:02 p.m. or whatever it is, right? Like, you ever wondered how they know? Like 4:02, that's kind of a random, thing. It's because that's what the calculator split out, or the computer system spit out according to the wind speed, right?
Isn't
Okay.
it like a profession? Like, starts with an A.
An actuary.
Yeah.
Yeah. They deal specifically with like insurance companies and stuff. So like, how good of a driver are you? Have you been into an accident before? How much should we charge you per month? Like, that's what the actuaries do, but they crunch numbers like that also. Yeah, yep. Okay, all right, this guy right here, if we're looking at our denominators, the 6 plus r, what does he need? He needs 6 minus r. All right, let's do the math. Here we go. This 5, what does he need?
Plus.
He
6
needs
plus
6 plus r, okay? And what's the 3 need? He needs both of them. Okay, all right.
Where's
Now,
my
the really nice thing is that, my favorite part,
I'm just gonna pick with this one.
cross off the bottom. We don't have to worry about the bottom anymore. Blech. Okay, are you running out of room? You're gonna have to write underneath of this box, and you're gonna write have to write over there to the side. Okay. Okay, here we go. Let's distribute the 5 through. So 5 times 6 minus r, that is 30 minus 5r. Got it? Okay, now let's distribute the 5 through again. That is another 30 plus 5r. Hey, that's nice. Equals. Okay, we're going to multiply this stuff together. What would you like to multiply first? You want to FOIL first and then multiply by 3? Sure. Let's FOIL first and then multiply by 3. All right, so we got to FOIL. 6 plus r, 6 minus r. All right, what's 6 times 6? 36. 6 times minus r.
6r.
Minus 6r, okay. R times 6
Plus 6r.
is plus 6r. And what's positive r times negative r?
Negative r squared.
Negative r squared. Got it?
Mm.
That's my FOIL. All right, the really nice thing is that
6 crossing.
the middle part crosses off. So I have 36 minus r squared. But I'm not done with that because I have to multiply that by
Really?
3, right? You see that 3 there? Okay, so we FOILed, now we're multiplying by 3. All right. Last thing, what's 3 times 36? I'm going to put him down here.
19.
108. 90 plus 18. Yeah, 108.
Exactly.
Okay, minus, what's 3 times negative r squared?
3 r squared.
Minus 3r squared. All right, here we go. Now we're down to this. What a mess.
What?
All right, now what would you like to do? The 5 r's can cancel, right? Okay, and then what does this become on the left side? 60 equals
108.
108 minus
3r squared.
3r squared. All right, now what would you like to do?
Put the 108 on a side.
I'm going to minus the 108. We're going to get a negative, but that's fine. Okay, what's 60 minus 108?
Negative 48.
Negative 48 equals negative 3r squared.
Now divide minus 1.
Divide by, I'm going to divide by minus 3.
Yeah, of course.
Yeah?
Mm.
Okay,
Makes sense.
what's negative 48 divided by negative 3?
Plus something. I don't know.
It's plus something.
16.
16 equals r
Okay.
squared. Oh, look at how nice that came out.
Divided by 2.
Nope, not divided by 2. This thing.
Take the
Oh,
square
so
root.
4.
The square root. So, what's that mean?
4.
The rate of what?
Rate of speed. Hour. Time. I don't
The
know.
rate of what?
I didn't even read the question.
The what? The rate of the water. That's the rate of the current.
Yeah,
So,
of course.
I'm rowing at 6 miles an hour. If I'm going with the current, it's going to feel like I'm going. How fast?
2.
What?
2.
No.
10.
10, right? I'm going
It's
with the
plus-
current. It's adding 4 miles per hour to me. It's pushing me more.
Plus this.
Okay? If I'm going against the current,
2.
it's slowing me down. It's going to feel like I'm only going 2, right? Okay? That is an icky problem. Okay? The rest of them are nice. So let's get down to this one. Okay? Number 2, your airplane speed. You have to do that one for homework, but it's pretty similar. You're going to end up with big numbers. But your final answer is going to be a little bit smaller. It's in like the hundreds. It's like 100 something. Okay.
Must just be young.
All right, work problem. Okay. We'll do 2 more and then we'll be done. Every year, we're going to see if the junior and senior class are like worth a darn, all right? The junior class and the senior class, they are building at Hillcrest High School. They build a house for the community, right? You guys have heard that before where you go on like mission trips and you help work on a house or whatever. Okay, the junior and senior class together put together this house, right? All right, if it takes the senior class 24 days to complete a house by themselves, so it takes them 24 days by themselves to complete the house, okay? And it takes 18 days if they work together. So I'm going to say together, they get done in 18 days. How fast would it take the juniors if they worked by themselves?
30.
You think?
I don't know, I just said it.
So 24 days for the senior class, 18 days if they work together. How many days will it take the junior class? Here's how you figure this out. All right? Again, they have this box here. You can see how that relates to our equation, but we're going to have the rate of the juniors. We're adding that to the rate of the seniors to make a total rate. Okay? The total rate. All right, now here's the deal. We're talking about rate again, which is kind of like what we did in the problem above, right? The rate. Let's talk about the seniors, for example, right? If they finish a house in 24 days, how much of the house do they get completed in 1 day? If they finish the house in 24 days, how much of the house do they get done in 1 day? 1/24th, right? So they work at a rate of 1 out of 24. Now, that is on average. Some days they might be more productive than others, right? But on average, they get 1/24th of the house completed in any day, in 1 day, right? 1/24th of the house. All right, how much of a house do they get done in 1 day if they work together? 1/18th, right? Okay. Now, we don't know what the junior's rate is, so we're going to call it X, and their rate would be 1/X, right? Okay. From here, it's a lot easier. The rate of the juniors, we don't know what their rate is, so we call it 1/X. Plus, the rate of the seniors is 1/24 equals the rate total, which is 1/18. Okay? Now, this is a lot easier to find a common denominator than it was the problem above. We're looking at X, and we're looking at 24, and we're looking at 18. Okay? So, let's look at 24 and 18. What number does 24 and 18 both go into?
6.
Those numbers go into this number, though. Not that goes into 24 and 18. I want a number that 24 and 18 go into.
Oh. Okay, so
72.
72. 72, he is right. Okay, now, if you can't think of that, here's where you start. Ready? I start with a bigger number. Which one's bigger, 24 or 18? 24. Does 18 go into 24? No. The next number up from 24 would be 48. Does 18 go into 48? No. The next number up from 48 would be 72. Does 18 go into 72? Yes, so that's my number, okay? So I just do multiples of the bigger number. All right, so 72 is my denominator, but also it needs to have X. So 72X, 72X, and 72X, okay? And then I have 1, 1, and 1 on the top, and then I just have to multiply by what he needs. Okay? All right? This is a lot easier than the problem that we just did above. I promise. Okay? All right, comparing. What does this one need to be multiplied by? He needs a 72. Okay? This 24, what do you multiply by 24 to get 72x?
A lot.
X, 3x.
3x.
Yeah, that's a
3
lot.
times 24 is 72, so he needs a 3 and an x. Okay, what do you multiply by 18 to get 72x? 4x. Okay? All right. Now we're going to make all this mess go away. Ready?
Yeah.
72 with the sound effects and all, right? There you go. Okay? And that's what I have left over. How much, how nice is that to solve? Right?
Beautiful.
Minus 3.
Minus 3.
Some of you guys have the answer already.
72
Compare.
Equal X.
72 equals x. What does that mean?
That's the.
It takes the seniors 24 days to build a house. It takes the juniors
72.
72.
Whoa.
Juniors, any juniors in here? You guys are terrible.
I know.
Juniors.
Horrible kids.
Juniors are terrible. Now, this does not take into consideration, they did argue with me last period, does not take into consideration how many people are working on the project, right? Maybe the senior class has more workers than the junior class, right? That's true. So, we can't necessarily say the juniors are terrible, but according to these numbers, the juniors look terrible, okay? So there's that. Does this make sense? Okay, we're looking at the rates. All right, we're gonna do another one of these problems together, and this is where you need a number. All right, so I'm gonna give you a number.
No.
Don't cheat.
6.
There are numbers in this pot. Go around and figure out the rate at which you paint a house. Are you a fast painter or are you a slow painter? Megan, what'd you get?
16.
16. She's a semi-fast painter.
So do I put that back?
Nope. Wait, you just keep it. Just keep it.
Yep.
Yep. Okay, pass them around. Brian got
17.
17. He's a semi-fast painter. He's like an average. The fastest painter paints 9 hours. The slowest painter paints 24. I just know the numbers that are in that pot, right? 9 hours versus 24 hours. What'd you get?
19.
Avery. Avery's 19. We're getting some middle of the road ones. Kind of slower-ish painter.
Let's go.
Because I'm the oldest. They never work fast.
15. You're getting all the middle numbers. What'd you get, Jack? 10. Jack's a fast painter.
13.
Ethan got 13. He's a kind of fast painter. We got some middle of the road problems. Mallory's gonna get a 20. What'd she get? 11. She's a really fast painter too.
12.
12.
Hey.
Wait.
I'm gonna try.
And these guys are gonna be the slow ones,
I'm
the
gonna
slow
24.
painters.
No, I don't
We're
like
gonna
it.
get the 24.
Hey, look at the papers first.
I don't like it.
Take the 24.
Don't just
Don't
grab
look
a
at
number.
it.
Yes, take this. Take this one.
He's cheating.
Take this one.
He's cheating.
Is it
What'd you
24?
get?
It's 22.
22. Ha! He's a slow painter. What'd you get?
No,
No, you can't put it back.
no,
What'd you
no.
get? Ha!
What was it?
23. Ha! Hand it to me. I need a number.
Right.
I'm gonna be a really slow one too. There's
Well,
only a
it's
couple left.
fitting because I would not work.
I am number 14. Okay. All right, here we go. This is how this works.
Are we still?
Here's how the activity works. Ready?
Are we playing by
Everybody's gonna do number 3 with me. Okay, Mrs. Kovacher can paint a house in. My number is 14 hours. Okay. If you and Mrs. Kovacher can paint the house together in 5 hours, how long
Wait.
will it take you to paint? So Kovacher equals 14.
The free.
You equals we don't know. Together equals 5. Okay.
Oh,
So
when we put 14.
When we put 14 to the.
Yeah.
Kovacher plus you
You.
equals together or total.
Wait, do we put what we have?
All right? No, not yet. We're assuming you don't know what you have, right? We're assuming you don't know. Everybody's answer is going to be the same for this one. So don't use your number yet, okay? All right. How fast can I paint a house? Or what rate can I paint a house at? 1/14, right? Plus, we don't know what you are. You are 1 over X. We're going to assume we don't know what your number is yet, okay? Together, we can paint it in 1/5, right? 1 over 5. Got it? Okay, that's the rate. All right, now we find a common denominator. 14x and 5. What should our common denominator be? 5 is prime. I think 70? 70. 70. 5 is prime, so 70 has to be the number. Okay, 70x, 70x, and 70x. Okay? Alright, that's going to be my common denominator, and then it's going to all FOIL out. Here we go. What do you take times 14 to get 70x?
5.
5x, right? 5 and x. Okay? What do you take times x to get 70x? 70, okay? What do you take times 5 to get 70x? 14x. Okay? Alright, now it becomes easy. The bottom goes away. Alright, 1 times 5x is 5x. 1 times 70 is 70. And 14 times 1 is 14x. Okay? So we have this now.
70.
So we subtract the 5x over. 70 equals
11.
9.
Yeah.
Yo.
I could just free. I don't know.
Divide by 9. It's going to be like 6 and change. No. 7 and change. I can't math. 7 point what? 7 repeating? 7, we'll go 7.8. So it takes you, according to this, it takes you 7.8 hours to paint a house. You're all slower than that. Huh. 7.8 hours. All right, now you're going to use your number, okay?
No.
All right, you people who are gone today, here's your number. Ready?
24.
Yeah,
Yes,
there's
this is
24.
24.
Ah, they're the slowest ones. You have 24. Ha. So you are the slowest painters. Sorry. You're all going to have the same number, 24. Okay? All right. So, number 4, just so we know, just so we're clear, number 4,
You have to jump.
you can paint a house in blank hours. This is you. If you and a friend pair up, you can paint the house in 8 hours. How long does it take your friend to paint? Okay? So just like we did the problem before, you insert your number here. So you people watching this video, you'll insert the number 24. Everybody else will insert your number there. And then solve the problem. Got it? All right, let's go through 5 and 6 so you understand what you're doing. You are going to have to partner up with somebody. So somebody like sitting at your table. It doesn't matter. You can paint a house in, insert your number here. This is you. Okay? Your friend. I'm going to pick Megan because she's sitting next to me. Megan can paint a house in how many hours?
Okay, die Jahrschule fahren.
What are you?
13.
How many
No.
hours does it take Megan to paint a house?
No, we have the worst hours.
16?
It's okay.
Okay, so I picked Megan. Don't pick Megan. Pick somebody else, like somebody sitting at your table.
Gordy.
Okay, but there, or Brian, you can pick Megan, right? Okay, Megan, you'll have to pick Brian, right? Okay? Then you switch and you find a different partner. So you put you in here and then you pick a different person. So I'm going to pick,
What do you have?
like Delaney.
Number.
What is your number?
Delaney
12.
paints in how
No,
many
what
hours?
is it?
12.
12. There you go. Delaney paints in 12 hours. How long does it take for blah, blah, blah? Okay? So you people watching the video, you guys can use Megan and Delaney if you want to because you don't have anybody else's numbers. So there's that. Okay? Good?
Easy. Who I use?
All right, that's all I have for you. If you want to work together with those people that you partnered up with on 5 and 6, that would be a not so bad idea, right? Okay?
What'd you say?
I have bad hours.
There you go. All right, that is all I have.